Hey guys, welcome back. Pre-calculus Tuesday, April 28th. We're going to do a little graphing of complex numbers, finding the magnitude of that complex number and direction of that complex number. So it's going to be a lot like vectors. And so just to remind you, magnitude, we're going to do Pythagorean theorem. That means the distance. And direction, we'll do inverse tangent of A over B to find our angle. So pretty simple today. This shouldn't take too long. Complex numbers. We're going to get into graphing complex numbers here. All right. So if you remember from yesterday, complex numbers are a plus bi. And so that a plus bi gets turned into a coordinate that is just ab. So it's treated as xy in the plane down here. So you'll see right here it says real. This is the real axis. Up on top, it's got an im sitting right there for imaginary. So we'll just treat this a plus bi as an ordered pair. So we're going to take 8 plus 4i and turn that into 8 comma 4. And at that point, we're going to just plot the ordered pair. So we'll go out to the right 8. 1, 2, 3, 4. That right there is, 8 plus 4i. So that is the order. That is the complex number 8 plus 4i. Pretty simple. Now, as we continue and kind of move on here, this section has a penalty attached because the problems. I think I need a T. Nope. We're just going to go with a big H right there. This has a penalty attached because these problems are very simple. Now, what I've found is that if you're struggling, the help videos show you how to use the Delta Math. They'll also show you the math part too, but I think the best part about the help videos is showing you how to use the Delta Math program. So if you're struggling with how to click and drag and move things or whatever, then make sure you're watching the help videos, and that'll tremendously help out. Okay? So that's graphing of a complex number. Pretty simple. So now, once we get into, it's called finding the modulus, which will be the second section. What they're really asking for is the exact value. So what they're doing is they're asking us to find the magnitude. And I cannot spell today. Magnitude of that complex number. So if you remember, when we did magnitude of vectors, it was the square root of a squared plus b squared, otherwise known as the Pythagorean theorem. Okay. So what we're going to do is we're going to come down. I'm just going to go ahead and show you the graphic part of this. And we'll take this complex number and we're going to turn it into 8 comma negative 7. Right? Just to show you how this all works. So we're going to go to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. We're going to go down 7. 1, 2, 3, 4, 5, 6, 7. And we'll put an ordered pair right there. And so very much like we were doing earlier in the semester with trig, we'll draw a triangle that extends from the origin, okay, and the x-axis. So we had an 8 here and negative 7 there. And so what you're finding is you're finding this. I'll call it C because in the Pythagorean theorem, that's what you're finding. So if we took the square root of 8 squared plus negative 7 squared, you'll find the magnitude, or what they're calling the modulus of the problem. So that's 64 plus 49, which is the square root of 113. And so that is going to be what they want you to type into Delta Math. So they've already even told you, like, hey, you're going to probably use a square root. So when you come up to your answer, click on the square root button, get the square root in there, type 113, click submit, and you'll get your big green check. Okay? So this modulus of a complex number is just asking for the magnitude. So you're going to do Pythagorean theorem with the two values. And if you're kind of paying attention, you don't really need the triangle, because you'll notice that the two values that make up the triangle are the two values that are going to go into the square root. And so really all you need to know is that these two values, 8 and -7, become the a and the b. Square them, take the square root, and you've got your modulus, okay, which is the magnitude. All right, so that's the second section. This section does not have a penalty attached to it. So if you mess this one up, I won't penalize you for that one. Third section, so I'll draw it out and I'll kind of explain it the same thing. So now we're looking for what they're calling the argument of the complex number, and you'll notice that it says degrees. So hint, hint, make sure your calculator is in degree mode. But what we're finding here is the direction. Okay, so think of it as finding the direction of the vector like we did last week. And so we had tangent of theta equaled b over a. And so we ended up doing the inverse tangent of the b value over the a value, or the y value over the x value. Okay, so let's turn our complex number here into -8, -6 ordered pair. So I'm going to show you kind of what we need to be thinking about here. And I do not have my calculator, so you guys are going to have to help me out with some calculating. So bad, Coach Scott. Don't even have my phone with me. Oh, I know what I can do. I can grab my calculator on my computer. So I'll get that going. All right. So left 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So we're looking at a triangle. It's a third quadrant triangle right here. There's your theta. So what that means is when we get our answer, we're going to plug something up here into the answer, that value has to be a value between 180 degrees and 270 degrees, no matter what our calculator spits out. Our calculator is going to give us the reference angle, the angle that's just between the x-axis and the terminal side. So we're going to have to add whatever this value is to 180 degrees to get the third quadrant value. So make sure you do that, and I'll make sure I do that as well. So we went -8, -6. So this is where tangent of theta is -6 over -8. Remember that this is our A value, this is our B value, and so if you notice, B ended up on top, that's the -6, -8 ended up on the bottom, that's the A. So our theta, after you do inverse tangent here, I'm going to have to go to the calculator, make sure I'm on degree mode. Yep, quit. All right, so second tangent, I know you can't see this, -6. Oop, I'm not doing this right. -6 divided by -8, which gives me 36.9 degrees. So pay attention to your directions. It says to the nearest tenth of a degree. So here, I'm going to have to flip back. 36.9. 36.9 degrees. Now that's just the reference angle. Because we are in the third quadrant, okay, we have to make sure that we have an angle measure between 180 and 270 degrees. This 36.9 is coming from down from 180 degrees. So we have to add 180 to that, plus, take your calculator, add your 180, get 216.9. 216.9 degrees is going to be what we end up putting in our answer. Okay, so that one took a little bit more thought because you had to figure out what quadrant you were in, and you got to make sure that that angle measure that you answer it with has the correct value. Okay, this section also does not have a penalty associated with it, so it took a little bit more work. So I didn't want to penalize you if you got one wrong. All right, so that's the 3 different types of problems you'll see today with complex numbers. Basically, if you think of it as the vectors, like we did last week, then we're doing the same things. We're doing magnitude, we're doing direction, which means we're doing Pythagorean theorem, and we're doing inverse tangent. Okay. So our assignment is going to be 15 Delta Math problems, 5 problems like each of the 3 problems that I just finished. The first section contains a penalty because they're just plotting that point. If you need to, look at the help videos. Okay? They'll help you, show you how to graph those. All right? Okay, you guys have a great Tuesday.